A satellite has an orbital speed around the Earth of 5,000 meters per second. Calculate the orbital radius of this satellite. Well, we know that the satellite is moving in a circle around the Earth. So that means centripetal force is required. And gravity provides this centripetal force. So that means we can equate the two. We can say centripetal force is equal to the force of gravity. Well, the formula for centripetal force would be the mass of the satellite times its velocity divided by the orbital radius, which is what we want to calculate. And that's equal to the force of gravity, and we can use Newton's law of gravity, which is g, the constant, mass of the satellite times the mass of the Earth, divided by the orbital radius. Now we can simplify this by canceling the mass of the satellite. That doesn't matter. And we can reduce this further. So if we want to calculate the orbital radius, we're going to use this equation. So let me just rearrange it. And that would be the radius, the orbital radius, is going to be equal to the gravitational constant times the mass of the planet divided by the velocity of the satellite squared. So we just now plug and chug. The radius is going to be equal to the universal gravitational constant of 6.67 times 10 to the minus 11 times the mass of the Earth, which is provided to us, 5.97 times 10 to the 24th. Looks like there's a little mark here. So this is 10 to the 24th divided by 5,000 squared. So the radius calculates to be 1.60 times 10 to the 7th meters. So that's where the satellite is located. Now, this location corresponds to a medium orbit. Generally, we have four orbits. The lowest orbits are about 1,000 kilometers, plus or minus 500. And the medium orbits are about 10,000, and they go up as high as 20,000. And then geosynchronous orbits have a specific location of 35,768 kilometers. Now, this right here is approximately 10,000 kilometers above the surface of the Earth. So let me just show you that. We know that the total orbital radius, so we'll call that orbital, is going to be equal to the radius of the planet plus the, I'm going to call this altitude. Okay, so what do we have? The orbital radius. Well, let's estimate this. We know that the radius of Earth is 6.3 times 10 to the 6th meters. And we know that the altitude of the medium satellites, medium Earth orbiting satellites, that's what MEO stands for, is 10,000. So that would be 1 times 10 to the 7th meters. And you add that up, and that works out to 1.63 times 10 to the 7th meters, which is approximately this answer right there. So that's how we know that this is a medium Earth orbit.